Now we're going to try and develop a way of finding out the shortest distance between a given point and a plane. So when given an equation for a plane, you can always roughly sketch it. So if you set y to be 0, set z to be 0, then x must be 2. So the distance from here to here is 2. If you set x to be 0, uh, uh, z to be 0, then y must be 3. So from here to here it's 3. It's 3. And then if you set x to be 0, y to be 0, then z must be 1. So the height here is 1. So when given an equation of a plane, you can always roughly sketch it. And when given an equation for a plane, you can always obtain the normal vector. So the normal vector the normal vector will always be perpendicular to the plane in all directions. So it would be 90 degrees here, 90 degrees, and so on. It would be 90 degrees in all directions. So the normal vector would be 3, 2, and 6. So you trying to find out the shortest distance between a given point and the plane is really you trying to find out the the normal vector where it crosses that point. You see, if you have it too high up, it's gonna go past our given point here. If you have it over here, it's not gonna reach our given point. So we are looking for a normal vector where it crosses, where it hits the where we are looking for a normal vector where it will hit the given point. You see, if you have it here, it's going to go past. It's going to go past the dots in 3D. The dots will be in front of this normal vector. So there must be a point somewhere. There must be a normal vector somewhere on the plane where it will pass through the point, and the shortest distance will be the distance from here to here. That's moving along the normal vector. So but the problem is we don't know where this location is, because if you have it here as a base, as a base here, then it's going to shoot over the dots. We are looking for a normal vector where it will pass through the point. So the shortest distance will be from here to here if you're moving along this normal vector. But the trick is, the problem is, we don't know where we should base this location here in order for it to pass through a given point. So the trick here is to, when given an equation of a plane, we can always locate these 3 points easily. So we would choose any of the 3 points. So we would choose this one. Let's just choose this one. We would extract the normal vector. So that will then give us this. So don't forget, this normal vector here will be perpendicular to the plane in all directions. When given an equation for a plane, we can always obtain this location here. What was it earlier? It was 0, 3, 0. So the location of this point will be 0, 3, 0. When we have the location here, we can always find this vector from here to here, and then once we've got this vector here, we will then project this onto the normal vector, and then the shortest distance will be this distance here. I will elaborate more on this. We've done projection before. When given two vectors, you can always project one vector onto the other. So this distance here along this direction, I will elaborate more on this, but that's a general idea. You obtain this vector here, and then the shortest distance will be you projecting this onto the normal vector, and then the shortest distance will be this distance here. Okay, I will elaborate more on this in the next video. Okay.